So an electrolytic cell is the opposite of an electrochemical cell in the sense that instead of using chemistry to produce electricity, we're using electricity to produce chemistry. Electrolytic cells are typically used for plating one metal onto another metal, which we call electroplating. Electroplating has uses in industry and probably in your household too. If you have any actual silverware, not flatware, but silverware. Silverware is not typically solid silver because silverware typically is plated with silver on the outside but is another metal underneath. You may also see it on some automotive details. So if you notice on a car that it's chrome, it may be chrome plated if it is actually chrome. You may also see it in some jewelry. Some metals are more expensive, and so they will make the piece of jewelry out of one metal and then plate it with a more expensive or precious metal. So down below we have a diagram sort of showing what an electrolytic cell would look like. Essentially what you're going to see is a power source, and that power source will always be labeled with a positive and a negative end. This power source connects the two metals. One will just be a simple electrode, the other will be whatever you want to plate onto. And notice that they are in the same container. So there's just the one container. So what's going to happen is, just like in the electrochemical cell, the electrons are going to come out of the negative end, but this time instead of originating in the metal, they're actually going to originate in the power source. If this isn't a battery, it will in some way indicate it's a power source. In fact, when I show this to you in class, if I haven't already, you'll actually see a power source. So the electrons are actually going to come out of the negative end of the battery, and they will gather on the item to be plated. In this case, it's a fork. Now, the tin itself isn't going to be gaining those electrons. Just like with the electrochemical cell, it's whatever ion is in solution. Typically, they will use an electrode on the other end that is the metal they want to plate, because what will happen is the electrons will need to be replaced in the battery, so they will actually come out of this electrode. And when they do that, they'll actually make, because they will be losing electrons, they'll be making ions of that metal, in this case silver. They typically also have silver in that solution. It's these silver ions that will pick up the electrons and plate themselves on the fork. So what's actually happening on the fork is that the silver ions are picking up those electrons and becoming silver solid. So you're actually going to see the silver start to plate itself onto that fork, covering up the tin that the fork is actually made out of. So that's the application of an electrolytic cell. Let's look at the chemistry that's actually happening here. It is the silver ions in the solution that we said are going to be picking up the electrons that gather on the tin fork, becoming silver solid. So whatever ion is in the solution will be gaining electrons. Therefore, it is reduced. Gain electrons reduced. So what is it that's being oxidized? Well, actually, the thing that's losing electrons is also the silver, but it's the silver solid that's losing those electrons. So we're going to have silver solid, that's the electrode on the left, becoming the silver ions that will later regain those electrons in the reduction half reaction on the tin fork. So this is our losing electrons oxidized. So in an electrolytic cell, the two coupled reactions actually involve the same metal. The oxidized metal is the solid, and the reduced metal is the one that's in solution. And those ions in solution are constantly being replaced by the oxidation of the silver solid. One of the things to keep in mind with an electrolytic cell is that it is not spontaneous. Since it is not spontaneous, it won't happen on its own. You're going to have to add energy, which is our power source, and in this case, a battery. So power or electricity is a reactant. Otherwise, it would not help. It would not happen. So how is it that electrolytic cells differ from electrochemical cells? They actually have just one cell, meaning one container, one beaker, but they have two electrodes in that one cell, unlike the single cell that only has the one. They also have a power source. Might be a battery, or it might actually say power on it, but they're forcing the reaction because they have a power source. Something else you might notice is that they'll have something to plate. In this case, you have a fork to plate. Let's try some examples on the back. So when you get one of these, you're going to be asked to do things like label the direction of electron flow, label where oxidizing and reducing is occurring, and identify which metal is being plated. Something else you may be asked to do is to write the half reactions. I'm going to add that in here because I think that it's good practice for us to do that as well. The first thing you're going to want to do is identify which end of the power source is negative, because that's going to be where the electrons come from. Those electrons will be replaced by pulling them from the electrode on the opposite side. So our electron flow is from left to right. On the negative side, the electrode that is on that side will have electrons gathering on it. So what's going to happen is electroplating is going to occur there. The ion that's going to be gaining those electrons will come from the other electrode, in this case silver. As it loses electrons to the wire, it will then create ions in the solution. Those ions are the ions that will pick up the electrons on the other electrode. So we already have our electron flow labeled. We need to come up with where oxidation is occurring and where reduction is occurring. So what's losing electrons over here is being oxidized, and the gain of electrons is happening over here for reduction. The metal that's being plated is the gold. In this case, Au is gold. And we've identified that right here. Our half reactions, doesn't matter which one you start with. You could start with over here, but our oxidation half reaction will be the gold, which is going to lose electrons to become gold plus 1. Our reduction half reaction is again gold, but it's the gold ions that are going to pick up the electrons gathering on nickel to become gold solid on the nickel electrode. Let's try another one together. The electrons come out of the negative end and are replaced by pulling them from the electrode on the opposite side. That means that the loss of electrons is occurring here on the B electrode, meaning that you're going to be making B ions in solution. The electrons coming out of the power source gathering on A will be picked up by B plus to become B0. So our oxidation half reaction is going to be B0 becoming B plus electrons, and our reduction half reaction is going to be the B plus picking up electrons becoming B0. Go ahead and try the other two examples. You're going to need to pause the video for a second and see if you can get them right without my help. In the meantime, I'll fill them in, and when you press play again, you'll see them filled in. Hopefully you did well in labeling your two diagrams. Go ahead and check your electron flow in each one, your oxidation and reduction half reactions, your label of Leo and Ger, where oxidation and reduction are occurring in each one, and what element is actually being plated onto the other one. There's one last thing that you should be able to do, and we can use the mnemonic device we've used in the past, is label the cathode and the anode. So wherever oxidation is occurring, anox, that's going to be our anode. Wherever reduction is occurring, that's going to be our cathode. Red cat gets fat, and that makes sense. This one's going to plate, it's going to get fatter. So this is going to be the cathode. Go ahead and label the rest of your diagrams with anode and cathode, and then you can check your answers. So go ahead and pause it, give it a try. Starting from the top here, we have our anode on the left and our cathode on the right. Cathode on the left, anode on the right. And at the bottom, the last one we have to talk about, anode on the left, cathode on the right. So that's how you label electrolytic cells and how you electroplate.